Okay, so what I'm going to do is I'm going to run through a couple of dot and cross diagrams, and hopefully by the end of this video, you're very clear on what to do. So if something similar comes out in your exam, you will get full marks. All right, okay? So now, first things first, I'm going to sketch carbon dioxide. Now, before you start dot and cross diagram, you need to have a couple of things. Number one, you need to know whether or not it's ionic or covalent, and you must know the chemical formula. So once again, you need to know if it's ionic or covalent, all right? And you must know the chemical formula. Okay? So, oops, MULA. Now, so carbon dioxide is CO2. All right, I tell you, let's just put it here, CO2. And we know that it is covalent because why both carbon and oxygen are non-metals. All right, okay? So non-metal usually forms covalent compounds. Then next, you got to list out your electronic configuration. Carbon is 2.4, oxygen is 2.6. This needs to gain 4 electrons, and this needs to gain 2 electrons. So once you determine all of that, we can start to draw carbon dioxide. Okay, so carbon dioxide is C, okay, carbon in the middle, and O, one on the left, and O, one on the right. Okay, now in order for carbon to become stable, it needs to gain 4 electrons. Now because there are 2 oxygen atoms, one on the left and one on the right, it will take 2 each. So it will take 2 electrons on the carbon on the oxygen on the left and on the right. Now because this is covalent, it needs to share 2 of its own electrons as well. So it's going to put in 2, and 2 must be fair. All right, I take 2, I share 2. All right, now because carbon only has 4 valence electrons, dots are electrons of carbon, all the 4 valence electrons already used up. So there should not be anything here and here. All right, so that should be empty. Okay, and for oxygen, now if I'm going to put, say, crosses as electrons of oxygen, oxygen has 6 valence electrons, 2 are used to form bonds, therefore 3, 4, 5, 6, 3, 4, 5, 6, and that is carbon dioxide. So if the question, of course, asks to draw everything, then please go and draw your inner electrons. All right, okay, so that's one. Now let's move on, part 2, all right, to C2, H2. Okay, so this is a bit interesting because why? The common question I get is, what goes in the middle? Or how does the molecule look like? So now carbon is 2.4, H is 1. All right, so we know that it's covalent because it's non-metal. We know the chemical formula, and therefore we can start. Now, carbon needs to gain 4, and hydrogen needs to gain 1. Okay, now, for dot and cross diagrams, typically the one that needs to gain the more electrons is in the middle, and the one that lesser is at the side. So the more electrons you need to gain, the one that needs to gain the most electrons is always in the middle. So in this case, we're going to put carbon atoms in the middle, because why? They need to gain the most electrons. And then hydrogen we put beside. Okay, so that's the first one. Now, the second one here is this, okay? In this case, although carbon needs to gain 4, it can't take 2 from the left and 2 on the right anymore. Why? Because hydrogen can only donate 1. H only has 1 electron to give. I can't give 2, I can't give 3, because why? There's only 1 electron in H. So each H can at most share 1, if I let crosses be electrons of H. All right, so let's talk about carbon on the right. Okay, so let's make life simple. Let's break it down. Okay, it's already taken 1 electron from the H, all right, on the right side. But it still needs 3 more, correct? Carbon needs to gain 4 electrons to become stable. It has already taken 1 from hydrogen. And because of that, it needs to take 3 more, right? It will take 3, 1, 2, 3. I'm going to write circles be electrons of the left carbon. It's going to take 3 more electrons from the carbon on the left. And now it has gained 4. It's done, okay? So carbon needs to gain 4 electrons. It's taken 1 from H, 3 from the other carbon. Okay? Now this is covalent. It needs to put in its own. So what I'm going to do, to make life a bit simple, I'm going to put dots shaded of the right carbon. All right? So 1, and then 1, and then 2, and then 3. So carbon needs to gain 4 electrons. In order to gain 4, it needs to share all its 4 electrons as well. So there should not be anything here and here. Okay, hydrogen, all right, has 1 to give. It has also gained 1, so hydrogen is stable. And let's not forget about the H here. Put a circle there, all right, for the electrons of the left carbon. And that is basically it. That is C2H2. Okay, so if you need me to repeat, what you can do is you can pause the video and rewatch that to make sure you have a clear understanding of what's going on. But once again, the one that needs to gain the most electrons is in the middle, all right? In this case, it cannot take 2 and 2 because H only has 1. So it will take whatever H has to offer, in this case 1 electron, It'll take the remaining 3 electrons from the other carbon. And that's why, in this case, you have a carbon-carbon triple bond there. Okay, so that is C2H2. Now let's move on to the next one, a bit more interesting as well. Okay, compound form when A and E undergo a reaction, A 15 protons, E 17. Now, so A, this is part 3, yeah, is 15 protons, 285, and E is 17, 287. So I'm listing down electronic configuration first, because why? For this, I have no idea what A and E are. All right, but just by writing it down, I realized that these two are nonmetals. This needs to gain 3 electrons, and this needs to gain 1. So A must gain 3 to become stable, E needs to gain 1. Now once I figure that out, I can say, oh, in that case, after gaining 3, A should form a 3 minus, E should form a minus. Now why am I doing that? I want to figure out chemical formula. It's AE3. Now it doesn't matter that they're both minus, all right? We're just using the numbers to figure out the chemical formula. Okay, so now we know that it's AE3, all right? We know that it's non-metal and non-metal, so covalent, all right? A needs to gain 3 electrons. The one that needs to gain the most is in the middle, so A is in the middle. And then E will be beside. 1, 2, 3. E, E, E. Okay? Now, because E has more than 1 electron, it's not the same as before where H can only donate 1. So A needs to gain 3 electrons. It'll take 1 from each E. So I let cross be electrons of E. Okay? And in order to take, it must give, it must share, right? So 1, 2, 3. I let circles be electrons of A. Okay, and then I'm just going to complete the diagram. All right, so E has 7 valence electrons. All right, 1 is used, 2, 3, 4, 5, 6, 7. So please don't forget to fill in the remaining electrons not involved in bonding. It's something students typically miss out, and then they end up losing some marks there. So make sure you have 5 circles and 7 crosses. And that is AE3. Okay, so this was a bit more interesting because why? Once again, we don't know what A and E are. So we have to figure out if it's ionic or covalent by looking at your electronic configuration. All right, once we know that they both need to gain electrons to become stable, they're both nonmetals, they'll form covalent. All right, figure out chemical formula by writing the charge and crossing down. Okay, so I hope you're clear on that. Now, part 4, I'm going to draw iodine. Okay, so iodine is I2, part 4. Now, why am I doing this? Because iodine, if you look at the periodic table, it's, I think, period 4, period 5, all right? So it's not something that you can do 2.8.84. No, all right, okay? So for iodine, all right, what you need to understand is that iodine is in group 7. And this means that each iodine will have 7 valence electrons. 7 valence electrons. Now, we don't know what the numbers are, 2 point something, 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 but I know that that one is 7. Okay, the middle we don't quite study, we just want to know that there are 7 valence electrons. Okay, iodine is non-metal, so we are going to draw once again a covalent molecule. I2, we're going to put 2 of them. Now because iodine has 7 valence electrons, it only needs to gain 1 to become stable. It'll take 1 by sharing 1 of its own. So that's basically it. Alright, now just in case you're wondering again, okay, I'm going to answer this question again. You could use all crosses. Okay, so I think if you want to, you can use all crosses. All right, 3, 1, 2, 1, 2, 1, 2. That's fine. All right, why? Because for your legend, you can go with electrons of iodine. I think that's perfectly okay. But if you're not comfortable with that, all right, or your school teacher says you must be different, then fine. You can go with circles like what I did previously. Hold on, 1, 2. Let me just replace all of that. Circle, circle. Sorry about that. And circle, circle. And then of course you can do cross electrons of iodine on the right side, and then circles will be electrons of iodine on the left. That is fine as well if you want to draw a legend. Okay, so watch out for elements that are in periods 4, periods 5. All right, all you want to do is you want to take note of the group, which will give you a number of valence electrons. Now, last one I think was CH2F2, I think. Yep, there we go. CH2 F2. Okay, so once again, non-metal, 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 covalent. All right. Now, carbon is 2, 4, hydrogen is 1, fluorine is 2, 7. So which is in the middle? the one that needs to gain the most electrons, in this case, carbon. Carbon must gain 4. This needs to only gain 1, and this needs to gain 1. So the one that needs to gain the most electrons is typically in the middle, that's carbon. All right, and everything else is just beside. It's F. You want to do FH, FH is fine, or FFHH is fine. It doesn't matter. Now, because it needs to gain 4, and there are 4 side atoms, then what can happen is that it will take 1 from each side atom. 1 from a fluorine, 1 from a H. So I'm going to let circles be electrons of H, cross be electrons of fluorine. Okay? And after taking 1, it needs to put in 1 of its own. It's going to share 1, 2, 3, 4 dots, shaded electrons of carbon. All right? Now, so that's it. Carbon is stable. Now, H only has 1 electron, so it's gain 1, it's also stable. We just need to complete the diagram for fluorine. All right, okay? 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. That's it. All right, okay? So I hope these 5 dot and cross diagrams have given you a clear idea on what to do the next time you come across one of these. All right, okay? So that's basically it, and see you next time.